Yep. So next, so I'm just going to repeat. So we're just going to find the slope with the point in question and 1 point below, and the slope with the point in question and then 1 point above. So that's two slopes. And then let's see. Let me know what you get. 6.7, 20, 6, 8. No, sorry. That's 14.7. 6.9. Let me know when you're done. Okay, and then do you know the final step? You're supposed to take the average of these two slopes. So just add them together and divide by 2. And then compare this. So this is the final answer, 6.8. So yes, and I was going to say, and compare this to the other method that we used, and we should get a very similar number. Was it the same answer? Okay, perfect. So we got 6.8 using both different techniques. So that's how you know that both techniques are working. And they also told us to do 2002. Yes. So instantaneous rate at 2002. Now you just pick any one technique you want. I just wanted to use both techniques at least once, but now it's your choice. Which one do you want to use? Which is you just skip the middle point entirely. Yeah, it's easier. So yeah, so 2002 is the middle point, and we're just taking the point above and below and just taking the average slope. So that's going to be 30.8 minus 21.6 over 2. Let's see what we get. 9 by 2 divided by 2, it's 4.6. So that's the instantaneous rate for the year 2002. You got that? Perfect. So now it's asking you, for C, it's asking you to compare the values from A and B. So for A, what was the average rate between 1999 and 2003? Do you remember? What did we get? 12.7. All right. So the average rate was 12.7. Say it again? Oh, sorry, 5.7. And for 2000, we got 6.8. And for 2002, we got 4.6. So that shows us that though it's close to 5.7, the instantaneous rate is different. And the average rate is kind of like the average between the two, probably. Okay, pretty straightforward. Parent function is x to the power 4. So the first thing you always do is you make a table of values for your parent function, and you usually have at least 5 key points, 0 being the center of them, and then you go above and below. So 2, 1, 0, negative 1, negative 2. Your y values are going to be, well, what's 2 to the power 4? 16. 1 to the power 4 is just 1, 0 to the power 4 is 0, and then negative 1 is also 1, and this is also 16. So this is my parent function now. 0, 0, 1, 1, and then 216. And then obviously on the flip side, we have the same points. And this is going to be messy for me, but yeah, perfect. So that's the parent function. Let's now do the transform function. First thing you need to do is label your AKDC values. I'm not sure what your teacher uses, but I usually have A as my first number here, the leading coefficient usually. Um, this is my K value. This is my D value. This is my C value. Does your teacher use a different set of letters? Okay, so so write these down. So A is equal to what? Perfect. What's K? No, it's 1/2. So I'm going to teach you, maybe this might confuse you because it's different the way your teacher teaches you, but the K value is actually 1/2, yes. What's D? +1. Perfect. And C is 7. Perfect. So that the trick here is D is always the opposite sign, so just be careful of that. And your mapping notation is as follows: X over K plus D. Oh man, that K looks bad, but yeah. And then AY plus C. So these are your mapping notations. You're going to make another table of values, and your headers for this are going to be the mapping notation values. So what's X over K? K is 1/2. So if you're dividing by 1/2, what you're really doing is multiplying by 2. Okay, I'll show you the long form of it in case you need to know. So X divided by 1/2, right? So X times 2 over 1, which is 2X. Get it? Perfect. So whenever you're dividing by a fraction, you always flip it and change it into multiplication. So it's 2x plus d, and my d value is 1, so that's going to be 2x plus 1. And then ay plus c, well, a is -1, so that's going to be negative y, and then plus 7. So this, exactly, yeah. So yeah, just 2 goes there, 2 times 2, 4, 4 plus 1, 5, and then that's obviously 3, that's 1, and you'll probably see a pattern, but just keep going. Yeah, -1, and then -3. And as for this, this is just negative plus 7, so negative 16 plus 7, -9. -1 plus 7, +6. 0 plus 7, 7. -1 plus 7 is 6 again. -16 plus 7 is -9. And then you just graph it. And you say you know how to graph, right? You know how to put the points in. 5 and -9. Alright, so then I won't do this, or do you want me to complete it? Okay, fine. Sounds good. Okay, so let's see. Even or odd degree. What do you think, this one? Perfect, yes. Why? Yes. It's opposite. Yeah, odd. Perfect. Sign of leading coefficient. Negative. Perfect. Yeah, good job. Domain and range. Yeah, just everything. Yeah. Symmetry. Yes, point. Because usually if it's odd, it has point symmetry. And then end behavior is pretty easy as x goes to infinity, y goes to, I guess, what? Negative or positive? What do you think? Positive infinity. As x goes to positive infinity, y goes to what? Yes. And then obviously opposite. All right, cool. Next one. Even or odd? Even, yes. Yep. Okay. Greater than or equal to 0, and that's y, just so you know. Reason being is the function is above. So it's wherever the function is, right? So if the function is above 0, then it's y is greater than or equal to 0. Symmetry, line. Because there's a mirror image right down the center. Point symmetry is when you take a point and then you rotate the function 180 degrees along that point, and you'll get back to that same point. So, oh, whoops, damn it. Doesn't matter. Okay, you know the rest. The end behaviors, you know how to do. Okay, sure. So I was gonna show something. Let's see this. So if I were to take this, right, and I were to rotate this, that's 90 degrees, and that's 180 degrees. So does this function look how the original function looked like? And if you can't see, I'll just have both of them up at the same time. See how it looks exactly the same? So when you rotate it 180 degrees, like the way I did it, so you can physically take your paper and like rotate 100 degrees and be like, hey, you know what? It's exactly the same. Well, guess what? That's point symmetry. So there you go. And that's usually for odd. Any